This is the review for Unit 4, video key for the study guide. So starting out, we need to find the a value in this polynomial. So we're going to solve our factor here, x minus 7, by setting it equal to 0 and solving for x. That's going to be the number that goes in the little box. Then our numbers across the top, we have 1 for the x to the 4th, negative 4 for the x to the 3rd, the a value, the negative 8, and negative 42. So we're going to go forwards as far as we can. So drop the first number, which gives us a 1, times 7 gives you 7, minus 4 is positive 3, times 7 is 21. Now I don't know what a plus 21 is, so we're going to stop there. And we're going to go to the very end of the problem, and because we are told that this is a factor right here, we're going to put 0 down here because that means there's no remainder, which means to get that, we'd have to have positive 42. To get positive 42, we'd have to multiply 7 by 6 right there. To get 6 from negative 8, we'd have to add 14. Right? And then to get 14 from the bottom, we'd have to multiply 7 by 2. So this becomes our equation. We're going to have a plus 21 equals 2. Subtract 21 from both sides, and a will equal negative 19. And that is our answer. Same idea for the next problem. We're going to have x plus 3 set it equal to 0, so x will equal negative 3. We're going to put that number in our little box. Our numbers across the top are 1, 9, c, and 15. So drop the first number, which gives us a 1, times negative 3 is negative 3, plus 9 is positive 6, times negative 3 is negative 18, which we can't go any further. But again, because we are told that this is a factor, the remainder will be 0, which means this has to be negative 15. We get negative 15 from negative 3 by multiplying it by 5. All right, so now that is gives us our equation. We have c minus 18 equals 5. We're going to add 18 to both sides, and c will equal 23. That's it. Okay. This next one says use synthetic division to find another factor, given that this is a factor, x plus 7. So we're going to have x plus 7 equals 0. Solve for x, which gives us negative 7. So negative 7 is going to be in our little box. And on the top row is going to be 2, 11, negative 17, 26, and negative 14. All right, now because we're told that this is a factor right here, okay, we know that when we're done with this whole problem, the last number we write down should be a 0. If it's not, then you've done something wrong and you should go back and check your work. So we drop the first number, which is a 2, times negative 7 is negative 14. All right, negative 14 plus 11 is going to be negative 3, times negative 7 is positive 21, which gives us positive 4 when we add, which gives us negative 28, negative 2, positive 14, and 0. So now to write our answer down, unlike the ones we just did above, we don't have a missing variable we're solving for. We want to know the remaining factor that we just found. Okay, so we start out with x to the 4th up here, so we divide it by an x, so we get 2x to the 3rd minus 3x squared plus 4x minus 2. And that is the factor that we're looking for. Okay, so we go to the next question. Sorry. All right. Now, people were somewhat confused about this piece right here. That's just a fancy way of saying we're dividing these two things. So it's just a different type of notation. It's nothing new. Okay. We take the x minus 4, set it equal to 0, and solve for x, which gives us positive 4. So that's the number that goes in our little box. Now, this type of problem is a problem where there's missing terms. You can see we have x to the 4th and then a term with no x's. But you have to account for the fact that there are other x's that exist in this problem. They just have coefficients of 0. So for x to the 4th, we have 1. For the x to the 3rd, we have 0. X squared, we have 0. X, we have 0. And then the no x is negative 256. So we're holding the place for the x to the 3rd, the x squared, and the x value that aren't in our problem, but we have to hold their place by putting down 0. All right. Let's erase those so it's not confusing in there. All right. So we do our box. Drop the first number, which is a 1, times 4 is 4, plus 0 is 4, times 4 is 16, plus 0 is 16, times 4 is 64, plus 0 is 64, times 4 is is positive 256, which gives you 0. All right, so our remaining factor is going to be x to the third plus 4x squared plus 16x plus 64. Okay. Again, here's our term we're going to divide by. So x plus 2 is equal to 0. X will equal negative 2. Put that in our little box. Again, this is a part where it has missing terms. So we have 1x to the 7th. We have no x to the 6th. We have 1x to the 5th. We have no x to the 4th. We have negative 10x to the 3rds. We have no x squareds, no x's, and we have negative 12. I'm going to put this stuff over to give me some more space. Okay. So we have a lot of terms that are missing. We have to count for all of them. So now we just drop the first number, which is a 1, times negative 2 is negative 2, plus 0 is negative 2, times negative 2 is positive 4, gives me 5, times negative 2 is negative 10, which is negative 10. Add it to 0, which gives me 20, gives me positive 10, negative 20 again, negative 20, times negative 20 is positive 40, which gives me 40, and then negative 80, which gives me negative 92. Okay, so this problem has a remainder. Okay, so we're going to have, we started with x to the 7th, we have x to the 6th, minus 2x to the 5th, plus 5x to the 4th, minus 10x to the 3rd, plus 10x squared, minus 20x, plus 40, and then minus 92 over a remainder of x plus 2. Very long answer. All right, and just good practice for synthetic division. All right, moving on. In this case, you're given a polynomial and a graph. So this is going to help us because our graph tells us one of the factors. So if you look at the graph here, we have a point here at negative 6 and a point here of I have no idea. So we're going to use the point that we do know of negative 6 to help divide our quadratic here to find its other factor. So I'm going to do it over here. So I have negative 6 is my number in the little box, and I have 3, 11, and negative 42. So I drop the first number, which is 3, times negative 6 is negative 18, which gives me negative 7, times positive 6 is 42, which gives me 0. So these numbers are my second factor. I have 3x minus 7. But the question wants to have both factors, so that's what we're going to write down here. So I have 3x minus 7, and then the other factor is the one that we used to divide. This is our other factor. We're going to write it as a factor. Right now it's a solution. So it right now says x equals negative 6. We're going to add 6 to both sides to make it x plus 6 equals 0, and this is our factor. So we're going to write that down next to the one we found using synthetic division. Okay. Same idea for the next question. It's just a bigger problem. We have a point here, which is at negative 1, a point here, which we have no idea, and a point here, which is positive 2. So we're going to use the points that we do know to divide the polynomial that we have. I'm going to start with negative 1. So I have 7, negative 10, negative 11, and positive 6. So I drop the first number, gives me 7, times negative 1 is negative 7, which gives me negative 17. Times 1 is, negative 1 is going to be positive 17, which gives me positive 6, times negative 1 is negative 6, okay, which gives me 0. So that worked out nicely. So that was the first term that we did know. So that's the negative 1. Now we're going to use the other term we do know, which is 2, and divide our answer that we just got to find the last factor that we don't know. So we're doing synthetic division twice. Again, we drop the first number, which is 7, times 2, which is 14. Add to negative 17 gives us negative 3. Times 2 is negative 6, which gives you 0 again. So this is our last factor, 7x minus 3. So we're going to put that down here, 7x minus 3. The other two factors are the factors that we had as answers. So we had x equals negative 1 and x equals positive 2. We're going to add 1 to both sides to give us the factor. Then we're going to subtract 2 from both sides to give us the factor. All right, and those are the three factors of the polynomial graphed in red. Okay. Next, want to use synthetic division to find out what f of 5 is. Okay, so when we're done with synthetic division, the last number that we have is going to be the answer for f of 5. So we're going to use 5, since it's already solved, for synthetic division. We're going to write the numbers up top across. We got 2, negative 4, 1, negative 6, and positive 2. All right. Drop the first number, which is 2, times 5 is 10, which gives us positive 6, times 5 is 30, plus 1 is 31. I don't know what 5 times 31 is, so I'm going to put that in a calculator. 5 times 31 is 155, minus 6 is 149, times 5 is 745, plus 2 is 747. So the answer to this question is f of 5 is equal to 747. That's how you answer this question. Same thing we're doing for the next one. We have negative 3, and then the values in our problem, which is negative 1, positive 7, positive 2, negative 3, and negative 8. Again, remembering that the signs follow the numbers. Drop the first number, you get negative 1 times negative 3 is positive 3, which gives you 10. Multiplied by negative 3 is negative 30, gives you negative 28. Don't know what negative 28 times negative 3 is. Negative 28 times negative 3 is 84. Minus 3 is 81. 81 times negative 3 is negative 243. Minus 8 is negative 251. So f of negative 3 is equal to negative 251. Okay. Here's an oldie but goodie from first semester. We just want to multiply everything out or combine like terms that with whatever we've got going on to see if the two terms or the two expressions or functions are equal. So let's look at the first one. For this piece, we're multiplying x minus 2 times itself. That's the first step that we have to do before we multiply the negative 3x to all the stuff inside. So we have to use the exponents first. This will give us x squared minus 2x plus 4. We still have that negative 3x out in front. Now before I multiply the negative 3 to the inside, I'm going to combine the like terms on the inside of the parentheses. So I have x squared minus 4x plus 4. Now I'm going to multiply it by 3x. So negative 3x times x squared is negative 3x to the third. I'm going to get plus 12x squared, and then minus 12x. So that is the answer to the first expression, or first function rather. Okay. Next, we have to go to the other one. So this one, I don't have anything that's got to be squared. I'm just multiplying stuff through. So positive 3x times negative x squared is going to be negative 3x to the third. And then 3x times 4x is positive 12x. On the other side here, we have minus 2 times 6x, which is going to be, x squared. Negative 2 times 6x is negative 12x. And those things are the same. So the two things are the same. So are they equivalent? Yes. Yes, they are. That's all I got to put. Okay. When it says justify your answer, that's by showing your work. All right. We're going to do the same idea with the next one. We have to multiply the stuff in the parentheses. X times x is x squared. X times 5 is 5x. Negative 3 times x is negative 3x. Negative 3 times 5 is negative 15. And then we have a plus 2x on the back end. It's just hanging out. Combining the like terms, the x squared is all by itself. We have 5x minus 3x plus 2x, which is going to give us 4x. And then minus 15. So that's the first answer. Next, I'm going to just rewrite the first parts, negative 15 plus 3x. I'm multiplying negative 2x times the stuff inside the parentheses. So I'm going to get negative 2x squared and minus 8x. Okay. Now I combine the like terms. I have negative 2x squared. The x's give me negative 5x and then negative 15. And that's my answer for this. Well, those two things don't look alike, so this would be a no. Okay. Next, we're doing quadratic inequalities. To solve these, the first step you need to do is we have to put everything equal to 0. So we're going to subtract the 8 to the left. So I'm going to get x squared plus 2x minus 8 is greater than or equal to 0. Now I can factor this. The two numbers that multiply to be negative 8 but add up to be positive 2 are x plus 4 and x minus 2. So 4 times negative 2 is negative 8, and 4 minus 2 is positive 2. Okay, so I'm going to solve both these for x. So x will be negative 4, and x will be positive 2. So next I'm going to graph these. I'm going to make a sketch. I have negative 4 and positive 2. It doesn't have to be perfect. It's going up because the x squared term in the problem is positive. Right here. Okay. And now you're just going to do a highlight on where the graph should be. So it says greater than or equal to. So I want to be above the x-axis. I want to be here. So I have to write my interval notation along those points, or along those highlighted sections. So I'm starting off at negative infinity all the way to the left, which has a parentheses on it. I'm going to negative 4, which is right here. Now, because the sign on the inequality is greater than or equal to, I'm going to put a bracket. I'm going to have a jump. I'm going to start up again at 2 on the other side with a bracket, and I'm going to go towards positive infinity. And this is the answer for interval notation for that particular problem. Next, same idea. I have to get this set equal to 0 first, so I'm going to subtract 6. So I have 3x squared minus 7x minus 6 is less than 0. Okay, now I'm going to do bottoms up method. So 3 times negative 6 is negative 18. Two numbers that multiply to be negative 18 but add up to be negative 7 would be negative 9 and positive 2. I then divide both these numbers by the first term, which is 3, and I reduce my fractions. So negative 9 over 3 is negative 3 over 1. And 2 over 3 can't be reduced, so it's just 2 over 3. Now I have my factors. X minus 3 and 3x plus 2. I set both those factors equal to 0 and solve for x. So x will equal positive 3 and x will equal negative 2/3. Then do my graph. So I'm at negative 2/3, which is here, and positive 3, which is over here. The graph is still going up because the 3 is positive in the original part of the equation. It's going to look like this. All right. Now I do my highlighted part. Now the inequality sign says less than, so I want to be below the x-axis. This is all the stuff I'm looking at. So I'm starting off at negative 2/3, and it's going to be a parentheses because it's not equal to. It's negative 2/3, and I'm going to go towards positive 3, which is where I'm going to end with a parentheses. And this is my interval notation. All All right, here's another oldie but goldie from first semester. Describe the end behavior. So this is a pretty simple section. We're looking for two things to determine end behavior. I'll put a little chart in the middle to help you out. We have evens and odd. And this is discussing, the even and odd is discussing the biggest exponent, not the number in front of it. So the even exponent or odd exponents. Then we have positives or negatives. And this is talking about the number in front. Okay, so even pluses will go up like this. All right. Even negatives will go down. All right. Odd positives are going to go up. And odd negatives will go down. So that's what we're looking for. And then we can determine what the end behavior is. So in the first one, we have we have an even number, okay, and we have a positive number. So this is positive 3. So this is going to be even and positive. So the graph for this is going to look like this. So we have to determine the end behavior, where the arrows are going. So we write this as x approaches negative infinity as it goes to the left. The graph of f of x is going up towards positive infinity. As the graph goes to the right towards positive infinity, the graph is going up towards positive infinity. Okay, so we're looking for, as the graph goes to the left, which way is the graph going? It's going up. As the graph goes to the right, which way is the graph going? It's going up. That's what we're talking about. All right, next one. We have an odd degree. We have a negative number. So that means this graph's going to look like this. So as x approaches negative infinity going to the left, that's an ugly, there we go. As x approaches negative infinity going to the left, which way is the graph going? It's going up towards positive infinity. And then as x approaches positive infinity going to the right, oops, I missed a thing or two here. Excuse me, as x approaches, there we go, positive infinity. F of x, which is where the graph is going down towards negative infinity. And there is your end behavior. Next, inequalities of things that have already been factored. Now this is a problem on the formative for these, so please make sure you pay attention to this stuff. We have 3 different x values here. Here's 1, 2, and 3. So we're going to solve all of them for x. So we have x is going to equal negative 2, positive 2, and positive 3. So we're going to put all those down on our coordinate plane grid here. So we have negative 2, positive 2, and positive 3. Since this number is positive, we're going to go up. We just talked about that in the last couple problems. Now we're going to highlight where the graph is going to be greater than or equal to. It means it's being above the x-axis. So this is the part that we're looking at. So I'm going to write this in interval notation. So it goes from negative 2 with a bracket because it's greater than or equal to, and it stops at positive 2 with a bracket. Then there's a break. Starts up again at 3, and it goes towards positive infinity with a parentheses. Remember, infinities always have parentheses. All right, that's the first one. This has 3 different terms, 1, 2, and 3. 1, 2, 3. We're going to set each one of those x's equal to 0 and solve for x. So we're going to have x equals 0, because that's the first one, then negative 3, and then positive 5. So we have negative 3, 0, and 5. Now, again, because this term is positive, the graph's going to go up. All right, and now we are looking for less than, which is below the x-axis. We're looking for these values. So we started off to the left at negative infinity. All right, and we're going to -3. Now, because it's just less than, it's just a parentheses. And there's a break. We start up again at 0 and go to 5. And we stop. And that's it. We're done. Oh, some factoring. Love the factoring. Here we go. All right, first thing you should always look for is a greatest common factor. In this case, every term in here has at least a 5 in it and an x squared. So we're going to take all that stuff out before we do everything else. All right, so if we do that, we're going to be left with x squared plus 2x minus 8. Okay, now we can look at the stuff that's inside the parentheses and factor that. The two numbers that multiply to be -8 but add up to be +2 are going to be +4 and -2. I still have to have 5x squared on the outside. This is as factored as you're going to make it, and that is your answer. Part B is our factor by grouping, because there's 4 terms. We're going to group the first 2 and the last 2. Let's make this centered. All right, out of the first 2 pieces, we can take out an x squared. So we have 3x plus 4 left over. On the next 2 pieces, we have, what can we take out? We can take out a 6. Yes, which will leave us with 3x plus 4. Now these 2 things are the same, so that's a good thing for us. So we're going to have x squared plus 6 as our first factor, and 3x plus 4 as the second. Now in these types of problems, you do have to look for the fact that this part might be a difference of 2 squares. This is not. Okay, 6 is not a perfect square. Let's make sure that looks like a 6. And it's not a difference because it's being added. Okay, so this is your answer. Next, we're going to do the bottoms up method to solve this one. 6 times -3 is going to be -18. The 2 factors of -18 that make +17 would be 18 and -1. Divide both these numbers by the first term of 6 and reduce. I'm going to get 3 over 1 and -1 over 6. So I get x plus 3. That's an ugly 3. And I get 6x minus 1. And I've factored part C. Next, this, again, just like the first one we did in part A, looking for greatest common factors. You can take a 3 out of both of these. And you'll be left with x squared minus 25. Now what's left over in the parentheses is a difference of 2 squares. Both x squared and 25 are perfect squares, and it's a difference because it's minus. So these 2 things can be factored into x plus 5 and x minus 5. Don't forget the 3 on the front end. Right here, again, greatest common factor. They all have an x squared in them. Take an x squared out. We're left with x squared plus 4x minus 12. Okay, we can't take anything else out. Like you might think, well, we can take a 4 out, but x squared doesn't have a 4 to take out in front of it, so you can't. So we got to figure out what 2 numbers can multiply to be -12 but add up to be +4, and that would be +6 and -2. 6 times -2 is -12. 6 minus 2 is +4. There you go. Last but not least, 2 numbers that multiply to be -18 but add up to be -7 would be -9 and +2. With a quickie. All right, on to the word problems. Now, for these, you're going to need to do is use Desmos to solve these, so we'll get into that when we get there. The cost to keep an arcade open each month is $1,000. At the current cost of $5 per person, 400 people go there each month. The owner estimates that for every 20-cent decrease in ticket price, 20 more people go to the arcade each month. We want to make a profit equation. So P of X is equal to, we're going to do the money first. So how much does it cost per person right now? It costs $5. What is he planning to do to the price? He's going to decrease it by 20 cents. How many times is he going to do that? We're not sure. So we put an X. Then we go to the people that are coming. 400 people go to the arcade. For every 20-cent decrease, he thinks 20 more people will go. So we're going to add 20. How many times are we going to add 20? We're not sure, so we put an X. And then it costs $1,000 to keep the arcade open. So we're going to subtract 1,000 from the back end. Again, the easiest question on the test. If you got this part right, the first part right, A, you rewrite it. I'm going to get rid of the 0. It's not necessary. And it's got to be greater than 0 because we're trying to make a profit. So the left side has to be bigger than 0 to make a profit. All right, from this, next we're going to go to, oh, I don't have it up there. My apologies. Here we go. We're going to go to Desmos. We're going to type this equation into Desmos to find out its maximum. So we have 5 minus 0.2x, 400 plus 20x minus 1,000. There we go. So we have 2.5 and then 1,025. There we go. So we can't do 2.5, so we're going to have to round that. Okay, because it's strictly at 2.5, we'll go up. Okay, so we're going to say that the x value is going to be 2.5. Okay, or sorry, 3. X value is going to be 3. So x is going to equal 3. Remember, I'm rounding. X is going to equal 3. Okay, so what we have to do is we have to go back in and put 3 in for this equation. All right, so if I were to do this and put in 3 for the equation, oh, I just erased it. Darn it. We're going to do it in pieces. 5 minus 0.2 times 3 is equal to 4.4. So let's do this. 4.4. Okay, and then 400 plus 20 times 3 is 460. And then I got minus 1,000. So if I go back in here and do 4.4 times 460 minus 1,000, all right, I'm going to have a maximum profit. I'm going to write this down to show the other work. Oops. Equals $1,024. Okay. All right. Well, the next question, and just to recap that, all I did was put 3 in for here and here in the equation and then find out what the numbers are going to be. So I got 4.4 from the first set of parentheses, 460 from the second, minus 1,000 gives me 1,024. Okay. Now, for the next part, for part D, determine the lowest price the arcade can charge and still make a profit of at least, how much is that? $500 per month. So what we're going to do is we're going to put in our equation again. Got erased because I was a little clumsy. That's okay. Minus 0.2x, 400 plus 20x, minus 1,000. Okay, so there's our equation again. Okay, but we're going to make another equation. We're going to put y is equal to 500. Okay, and what we're going to see here is this purple line on the green line. So we want to know what's the lowest price the arcade can charge. So we're going to look for this intersection point. All right, it's 13.956. Now this is the issue. Now you think, well, it's really close to 14, but the problem is if we go to 14, it's going to be past, it's going to go to the right, which means it's going to go below the line, the purple line. So we have to actually round down to positive 13. Okay, we can't go up to positive 14 because, again, it will go to the right, which means it will be below the $500 mark line, which is the purple line. Okay, so we have to use 13. All right, so what we're going to do is the question is asking us the lowest price. The price is determined by the 5 minus 0.2 times the x value. We're going to use 13 as our x value. So 5, we'll put it in Desmos. 5 minus 0.2 times 13 gives us $2.40. That's our answer. Okay. All right, let's go back to Canvas here and make this a little bit bigger so we can see it better. All right, next one. A company is hosting a banquet for their employees. The cost of the banquet is $4,400. At the current cost of $90 per ticket, 160 people have bought tickets. I couldn't read that. The banquet organizer estimates that for every $4 decrease in ticket price, 11 more people will buy a ticket. So it's the same idea as last time. We have P of X equals, we're going to do the money first. So the current cost is $90. We're going to do a $4 decrease, just we're not sure how many times. Next, the people. There are 160 people coming to this banquet, but if we lower the price, we're going to have 11 more people come for each time we lower the price. So plus 11x. The cost of the banquet is $4,400. There we go. Again, the easiest question on the test if you got part A. Rewrite part A. And make it greater than 0. Okay, so now, like before, we're going to switch over to Desmos and write our equation in here. So we have 90 minus 4x. We have 160 plus 11x. We have minus 4,400. So we got to figure out where this is. It's a taller, and there it is. Come on. There we go. Okay. So we find this point. We got 3.977. So we're going to use x is 4. We're going to round up to 4. All right. So there's a couple questions in this part. I'm going to move this over a little bit to blow this up a tad. Okay. So there's 2 questions in here. Use technology to determine the maximum profit the company will make from the sale of the tickets. All right, that's the first question. And then what ticket cost will result in the company making the maximum profit? So we're going to find out both at the same time, basically. Okay, we're going to put 4 in for our equation. Okay, so if we did the first part, which is the ticket cost, is 90 minus 4 times 4 gives us $74. So $74. All right, then we're going to multiply that by 160. Oops, get rid of this. 160, nope, wrong thing. There we go. 160, aye. Hard to hit the little buttons. 160 plus 11 times 4 gives us 204. And we're going to minus 440. Or 4,400, sorry. So let's just delete this. That's better. So we had 74 times 204 minus 4,440. Or 4,400, sorry. So that gives us a grand total of $10,696. So that's the one question. That's the maximum profit. All right, this is the profit. And then what ticket cost will result in the company making the maximum profit? Well, this is the ticket cost. $74 ticket. So those are the 2 answers for this question. Okay. And the next piece, for part D, what's the lowest ticket price the company can charge and still make a profit of at least $10,000? Again, we're going to make our y is equal to $10,000 equation and find the intersection point. Okay, so this is a little bit tricky again. It's 7.955. You'd think you'd round up, but if we do that, we're going to drop below the 10,000 mark, which means we have to round down to 7. So if we put 90 minus 4 times 7, that's an ugly 7. I'll put it in here. 90 minus 4 times 7 gives us $62. Okay, there you go. Last one. Danny started a lawn mowing business and it cost $250 a month in gas and maintenance for the lawnmowers. When she charges a fee of $50 to mow lawn, she has 75 customers per month. Danny estimates that for every $5 increase in the fee, the number of customers will decrease by $2 per month. So again, we write our equation. We're going to write the money first. She gets $50 to mow a lawn. But she's going to increase the fee by $5. How many times? We're not sure yet. Okay, that's going to take her customers, which is currently 75, and decrease them by 2 per month. Not sure how many they're going to decrease by, though. And it costs $250 to do her business, to run it. All right. So again, easiest question on the test. 50 plus 5x. 75 minus 2x minus 250. It's got to be greater than 0 to make a profit. Again, we're using technology, so here's Desmos one more time. Write it out. We got 50 plus 5x, 75 minus 2x minus 250. And this is our graph. There is our parabola. Again, we have a decimal. It's closer to 14, so we're going to round to 14. So x will be 14. So again, determine the monthly profit Danny will make. And then how many monthly customers will result in the business making the maximum profit. So now, unlike the last problem where we had to find the ticket price, we're using the money. Now we're using the people. Okay. So there's two things we got to do again. We've got to put this into our equation for under 14 to find the profit. And then we're going to use one of those parts to tell us what the customers were. Okay, so let's do the first one first. So we got 50 plus 5 times 14 gives us 120. That's the money. All right. And then we have 75. Let's get rid of this. 70. Nope. Did that same thing last time. 75 minus 2 times 14 is 47. Why did that look wrong? No, that's right. Sorry. 47 minus the 250. Okay. So let's do 120. Did it again. 120 times 47 minus 250 gives us a grand total of profit, $5,390 of profit. Okay, now what we're talking about, how many customers, that would be this part. Okay, she's going to lose a bunch of customers, but she's going to make the most money. So we're going to have 47 customers. Okay, and the last problem, again, we're going to use y is equal to 4,000. No, not there. To find out where these two lines intersect, what's the highest fee she should charge? Still make $4,000. So, again, we have a decimal of 25.5. But again, if we go to 26, we round up. We're going to go below the $4,000 mark, so we have to round down to just 25. So her x is going to be 25. So we're looking to figure out the highest fee. So we put that into the money part, which is the 50 plus 5x. So if we do 50 plus 5 times 25, we'll get our answer. So 50 plus 5 times 25 gives us $175. That's an ugly box. Okay, well, that is all of the answers for the review sheet. I wish you luck in reviewing. If you have questions, please make sure you ask before the test on Friday.